All right, good afternoon. We are going to do a couple of things today. We are going to study two more types of problems that you might see on the AP test. So that's our last week. We've got to sum it up, right? Today and tomorrow. We're going to do tables in a different video. And we're going to review this again because I really feel like this is both, you need to understand the graph of the derivative as an instrument to find, relative maxes and mins, increasing and decreasing. But you also need to be able to look at this and be able to anti-derive, so to speak, and understand that aspect too, because that's usually the derivative is a and b, and then finding stuff about f is c and d. So being able to create the sign charts, we've kind of already gone over. Now I think I just want to do it again, and hopefully if we do it enough times, you guys are going to rock this test, right? Okay, so here we go. They give us a graph of f prime, and they gave us different areas underneath the curve. So this one, they already calculated the areas. You have done some examples where you're going to have to, calculate the area of a circle or the area under a line. And those are more like what you're going to see on your practice today. But I think you'll figure out how to calculate the area. I don't need to teach that to you today. Okay, so let's go ahead and start. So they gave us f prime, and they said it's twice differentiable function f. Okay, that's good. So all of our theorems apply. And they told us that these are horizontal tangents here. And what else did they tell us? The areas are labeled, talked about that, and the function is defined for all real numbers. Okay, and then they did give us an initial condition there. F of 8 is equal to 4, so that's kind of interesting. Okay, now it says find all values on x on the open interval for which the function has a local minimum. So immediately you're going to your flashcards, local minimum. What do I do? Okay, I take the derivative. Well, the derivative's already taken here, right? And I set it equal to 0, find those critical values, and then I'm going to put them on a sign chart. So we are going to do part A right here, and we're going to do a quick sign chart. So remember, if you're given the graph of f prime, this is the value of the graph. So you can see we're positive almost the whole way, except from, it looks like from 4 to 6 there. So at 1, we have a critical value. F prime is 0. It's positive, it touches 1, and then it comes back up. And then it hits 0 again at 4, right? 2, 3, 4. So at 4, we're at 0 again, we're positive. And then it goes to negative for 5, and then comes back to 0 at 6. And then it's positive again after 6 to 8. Okay, so we're increasing. This is F down here. Increasing, decreasing, and increasing. So we have a TP, local max, and a local min. All right, so now what was the question again? They were asking for find all the values for which the function has a local min. Justify your answer. So we would say f, or f of x, however, f has a local minimum at x equals 6 because f prime of x changes from negative to positive. All right, let's do part B. What do they want us to do for part B? B, determine the absolute minimum value of f on the closed interval and justify your answer. Okay, so now we not only have to check our local min, we know these two are not going to be viable options because it's a max and a TP. So we just have to put x and f of x. And we have to check our bounds. So we're going to put our bounds 0 to 8, and we're going to check 6 as well. Okay, so we need to figure out, well, we know f of 8 is equal to 4. So that's a great place to start, right? So if f of 8 is equal to 4, we know how to do this, right? So we're going to go from what we want to know to what we already know. Or you could go backwards. It doesn't matter. So for 0, I'm going to do, you know what? I'm not going to put this in the table. I think it's going to be too confusing. I'm just going to write the equation over off to the side here, and I'm going to do it in pink. Okay, so my equation is from 0 to 8, f prime of x is equal to, now when we're going to anti-derive here. When we anti-derive f prime, we get f, yeah. And we're going to do the top minus the bottom. So this is what we're looking for here. This is f of 0. That's what we want to know. So that's what we're searching for. And we know f of 8 is 4, so we can plug that in. And then this, we're going to figure this out. This from 0 to 8 is just the sum of all the areas, right? So this is the sum of areas in the graph. Okay, so this area is 2 plus 6 minus 3. Don't forget about that because that's a negative, plus 7. And that's going to equal 4 minus f of 0. Okay, so f of 0 is still what we're looking for here. So 2 plus 6 is 8. 8 minus 3 is 5. 5 plus 7 is 12. 4 minus f of 0. So I'm going to add my f of 0 over here. And 4 minus 12 is negative 8. So I get an answer of negative 8. Now we're going to do the same thing for 6. Here I'm using it. Oh, you guys could see most of that. Sorry about that. I'm going to do the same thing for 6. So, okay. Sorry, Lola wants out. Here you go, Lola. There you go. Okay. All right, sorry about that. Okay, 0 to 6, f prime of x is equal to f of 6 minus f of 0. Now we already know f of 0, and now we're looking for f of 6. You could have done it from 6 to 8 as well. It doesn't matter. Okay, and so again, this is the area under the curve up to 6. So it'll be 2 plus 6 minus 3 is equal to f of 6 is what we're looking for, and minus a negative 8. Okay, so we get 8 minus 3 is 5, and this is plus 8, so then I'm subtracting it. So I get f of 6 is equal to negative 3. So our absolute minimum here is at 0, okay, because it's smaller, obviously, than the other two numbers. So we're going to justify our answer here. So our answer is f of x has, can you see this? No. Oh my gosh, I'm so sorry. There we go. F of x has an absolute, if I could spell, so much easier. Absolute minimum at x equals 0 because f of 0 is equal to -8. And combined with your sign chart and your table and your work, that is the perfect answer. Okay. All right, part C, let's see. Okay, part C is on what open intervals is the graph of f both concave down and increasing? All right, well, we already know where it's increasing. So now we just need to do one more sign chart here. One more sign chart for f double prime. So, and remember, if we're given the graph of f prime and we want f double prime is the slope, okay? So the slope here is negative and it changes at 1. So 1 is a potential pi, or point of inflection. So that's negative. And then the slope is positive here up until 3. And then it switches to negative until we get to 5. And then it looks like it's positive until we get to 8. So this is concave down, concave up, concave down, concave up. Okay, and what are we looking for? We're looking for concave down and increasing. So let's look back at our other sign chart here. I don't know. Oh, I can't barely get them on here both. So concave down and increasing looks like from 0 to 1. Oh, open interval. So I should use the open parenthesis. Open interval 0 to 1. So it's increasing and concave down here. Then it goes to concave up until we get to 3. And then we're concave down again. So, and we're increasing from 3 to 4 still. So that's going to be from 3 to 4. We're increasing and concave down. And then we're decreasing till we get to 6. And then again, 6 onward, we're concave up. Oh, no, that doesn't work. Concave up and increasing, that's not going to work. Okay, we're concave down till 5, and that's decreasing. Okay, so those are the only two intervals where we're concave down and increasing, and we're going to explain our reasoning. So f of x is concave down and increasing on 0 to 1 and 3 to 4. Okay, and I'm going to erase this. Sorry, I shouldn't have written it there. 3 to 4. Because f prime of x is greater than 0 and f double prime of x is less than 0, sorry, on those intervals. Okay, and the last one, D. Okay, D says the function is defined, the function g is defined by g is equal to f of x quantity cubed. If f of 3 is equal to -5/2, find the slope of the line tangent to the graph of g at x equals 3. I have to think. Think. Let's see. Okay, so the slope of the line tangent to g, That slope means what do? You got it. Take the derivative, right? So I got to take the derivative of g here. So g prime of x is equal to, I'm going to power rule this, right? 3, keep the inside, f of x. Now this is squared, I subtract 1, and then multiply by the derivative of the inside. Don't forget the chain rule, right? Okay, so they're telling us now we want the slope at x equals 3. So g prime of 3 is equal to 3 times f of 3 squared times f prime at 3. Oh, and they told us, that's nice, f of 3 is negative 5 halves. So 3 negative 5 halves squared. And now f prime at 3, we have to go to the graph and find that. So this is 1, 2, 3. So f prime of 3 is 4 times 4. Okay, and we could do this. 3 times, the negative's going to go away because we're squaring it, right? So 5 squared is 25, and 2 squared is 4 times 4. What happens to the 4? That goes away. So g prime of 3 is 75. And that should be the slope there. All right, I think we did it.